Hey there, welcome back to Angie's Beyond the Lecture, and this is our chemistry final exam review, and we're going over the fundamentals or foundations of chemistry. Again, this is section 3, and we're just doing a quick review on our states of matter, which are typically solid, liquid, and gas. So hopefully if you've gone through the entire course, chemistry course already, whether it's high school or college, you're well aware of the types of matter that you're dealing with. Just as a reminder, solids have definite shape and volume, and the particles are tightly packed. So that means the molecules themselves, yes, they are tightly packed in nice, relatively neat arrangements, but their molecules do vibrate ever so slightly. Not that we as humans would notice, but yes, there are very, very small vibrations in those connections between those molecules. Now, in the liquid state, we do not have our definite shape. We do have a definite volume that if we can, of course, measure, and particles are close together but able to flow. And I'll demonstrate that here in a moment, how that looks in general. Gas, we have no definite shape, no volume. Particles are far apart and they move rapidly and freely. So relatively speaking, you could look, and I've seen this sort of demonstration here. Now, solid particles are going to have this stacked, right, arrangement. They're going to be really close together. And like I said, those, and this is just a generic view. It's not, a particular atom or molecule or substance, but it just shows how tightly they're packed. They have a definite volume, a definite shape. When you get to the water, they're going to be sort of together, sort of not, right? They're starting to sort of split apart. Okay, they're not as tightly packed. They're starting to split apart. We might have some over here, but you get the idea. So if you're given, for instance, a quiz or a test question, and it wants you to differentiate the particles and how they're arranged, and how would you identify solid, liquid, gas? Liquid are sort of in the middle. Gas molecules are, for instance, I'll put them in a container, far apart, rapidly moving, far apart. Okay, so those are the three ways it could be demonstrated in sort of a generic model. Now, that being said, we can classify these substances outside of the generic solid, liquid, and gas assignments. We can actually look at classifying matter into pure substances and also mixtures. Classifying matter. So we have these two categories, and these tend to trip students up, I think. And even as a long-term chemistry tutor and student myself, I sometimes need to review these definitions and the questions that you'll see. Now, pure substances, these guys have fixed composition, and you cannot separate them by physical methods, which tells me you have to have them engage in some sort of chemical reaction to get new products. All right, so this includes elements and compounds. So elements are just a single element. That could be, for instance, argon, O2 gas, right? Sodium, that's a metal in group 1. On the periodic table, we could be also looking at compounds. Those are 2 or more elements chemically combined. So we're looking at maybe H2O. That's our water. Carbon dioxide. I mean, the list goes on. NaCl. These are just our everyday compounds that we interact with. Okay. Glucose. C6H12O6. All right. Hopefully you get the idea there. Now with mixtures, this is a physical combination of the categories above. We'll just call them substances, but it could be a physical combination of 2 or more elements or 2 or more compounds. Okay, so to break down mixtures, we could have homogeneous mixtures, which are sort of uniform throughout. You really can't separate visually the different parts. And then we have heterogeneous mixtures. Those are non-uniform, and we'll go over examples with that. Back up to our definition, though, we have a physical combination of substances. the composition can vary, right? The difference between mixtures and pure substances are, if I have, for instance, oxygen, O2, in a container, I'm not pulling anything out of there besides O2. That's a pure substance. It's a single element. However, mixtures, a classic example, while we're in the gas concept here, is that the air we breathe is a mixture of different gases. We have largely oxygen, correct? We can have some nitrogen in there. We could hopefully not have too much carbon dioxide, and so on and so forth. So we have the air we breathe is a mixture of gases, of different types of gases, but largely oxygen. Now, breaking down our types of mixtures, we can take this down further. We have what's called a solution, and we call that, it's a homogeneous mixture, very small particles, uniform in appearance, and the whatever solid you put in to that solution is not visible. Okay, it doesn't settle out. And the classic example would be salt water, sugar water, air. That's another mixture. I can't, I look at the air in front of me, I can't tell what's oxygen and what's nitrogen, what's carbon dioxide, what else could there be? Pollutants, sulfur, and so on. But hopefully you get the idea there. When we do the Tyndall effect, or try to like hold up a flashlight to solution, there's no scattering of light in that. And very small particles here. So I'm going to highlight or just circle the size here. Now, traditionally, I don't see students being tested on the size, but just to give you an idea, the particles in solution are less than a nanometer. A nanometer is 10 to the negative 9 meter. It's a very, 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 very small part of a meter. Okay, 9 meters. All right. Now, colloids, those are medium-sized particles, anywhere from a nanometer to 1,000 nanometers. And it appears to be uniform. Classic example is milk. I think students think it's a solution, but technically milk is a colloid. And it appears, again, it appears uniform, but scatters light. So you're going to take perhaps a glass of milk and shine a flashlight on the clear glass that it's sitting in, it would scatter the light. And I think that's something that high school chemistry students engage in. They look at different examples of the Tyndall effect. And again, we have examples of milk, fog, and even the gelatin or jello that you eat. That is considered a colloid substance. Now, suspensions are the largest of all three. They're large particles. So we're talking greater than 1,000 nanometers. This would be non-uniform. You can see the boundaries between the different substances in the mixture and separate them out easily from a visual perspective. Particles do settle out over time, and yes, you would have scattering of light in that situation. Now, examples would be muddy water, sand in the water, orange juice. You can see the pulp floating around in the orange juice if you get pulp. I tend to get pulp free. I don't really care for that. It's a texture thing for me.